everyone and welcome to my channel. If you haven't subscribed to my channel yet, please click the subscribe button and the bell button for notification. For today's lesson, we are going to talk about Mathematics 7, Quarter 1, Module 1, that is all about sets. To start off, we have to understand what is a set. A set is a well-defined group or collection of objects that share common characteristics. So let's take note, well-defined. When we say well-defined, we can say that it is always clear. Clear in a sense of everyone's point of view. A set can be named using capital letters. Example. Capital letters. Example is the letter A, letter B, and so on. A set is composed of elements. These elements are enclosed in a bracket, like that. And it is always separated with a comma. Example, a set of even numbers. We have set A, capital letter, is equal to, open bracket, even number, numbers 2, comma, 4, comma, 6, comma, and so on, close bracket. These three dots are called ellipses. I have mentioned earlier that a set is always well-defined. What if it is not well-defined? Therefore, it is not a set. How can we say that a set is not well-defined? Let's have an example. Set of young politicians. This is not well-defined. Set of versatile actors. This is also not well-defined. Set of durable bags. This is also not well-defined. By looking at the examples, we can make a conclusion that a set is not well-defined if it contains an adjective. What is an adjective? An adjective is a word that describes a noun or pronoun. In our first example, the adjective is young. Second example, the adjective is versatile. In our third example, the adjective is durable. So it means that for one person, young is somewhere near 18 to 20 years old. For another person, young is about 18 to 25 years old. It means that this point of view is always subjective, based on the person that's talking about. Let's have examples of well-defined sets. Example, types of matter. We all know that the types of matter are solid, liquid, gas, and plasma. Another example is the set of planets in our solar system. We all know that we have 8 planets in the solar system: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Another example is the set of even counting numbers. Even counting numbers are 2, 4, 6, 8, 10, and so on. Therefore, in everyone's point of view, this is exact, this is exact, this is exact. Therefore, this is well-defined, this is well-defined, this is well-defined. These are examples of sets. Next is subsets. Subset is given any two sets, A and B, if every element in A is also an element in B, then A is a subset of B. The symbol A is a subset of B. So to make it easier for you to understand, another thing you have to remember is the null set. A null set is an empty set. It can be represented by empty braces or this symbol. This is the symbol for null set. The cardinality of sets is denoted by small letter n, open parenthesis, the set, close parenthesis, and equal to, is the number of elements in set A. Example, set A is equal to 1, 3, 5, and 7. Count the number of elements, 1, 2, 3, 4, therefore the cardinality is 4. Pretty easy. Let's have an example. Set B is equal to sun, moon, and stars. First, let's identify the cardinality that is denoted by n, open the parenthesis, b, close parenthesis, that is equal to 1, 2, 3 elements. This is the cardinality of set B. Now, let's find the subsets of set B. I am going to teach you how to easily find the subsets. Subsets of set B. Always remember that in all sets, null set or empty braces is always a subset. Therefore, null set is the first subset. Another one is, let's start with only one element. We have the sun, we have the moon, and we have the stars. Let's proceed to 2 elements per subset. We have the sun and the moon. Write it down as sun, comma, moon. Then the sun and the stars. Write it as sun, comma, stars. We cannot go back to moon and sun because it's already here. Always remember that the elements does not have an exact order. So it's already here now. We proceed to the moon and the stars. We don't have it yet. So let's have a subset, moon and stars. Then our last subset is composed of 3 elements, sun, moon, and stars. How would I know if how many subsets are there in a set? That is also easy. I will teach you how to compute it very fast. Remember, the cardinality is 3. In order for you to know how many subsets are there, 2, cardinality 3 raised to 3 is equal to 2 times 2 times 2. Now we have 2 times 2 is equal to 4 times 2 is equal to 8. Therefore, we have 8 subsets for a set that contains 3 elements. Let's count it. 1, 2, 3, 4, 5, 6, 7, 8. So, hindi natin huhulaan kung ilang subsets ang meron dahil alam na natin kung ilan siya. And if ever na kulang, pwede natin siyang balikan and i-recheck yung ginawa natin para malaman natin kung ilang subsets ba talaga dapat. Now, if you're going to ask me, how are you going to know how many subsets are there for every group of elements? We are going to use the Pascal triangle, which starts with 1, 1, 1, another 1, 1 plus 1 is equal to 2, and then 1. Another 1, 1 plus 2 is equal to 3, 2 plus 1 is equal to 3, and then 1. So this was for our example earlier. We just stop here. There is one subset containing 0 elements, that is 0 elements, that is the null set. And then we have 3 subsets containing one element, that is sun, moon, stars. 1, 2, 3. 3 subsets containing one element. 3 subsets containing 2 elements. We have the sun, moon, the sun, stars, and then the moon, stars. 1, 2, 3 subsets. And one subset for a subset containing 3 elements, that is the sun, moon, and stars. If you are going to add this up, 1 plus 3, 4, plus 3, 7, plus 1 is equal to 8. Therefore, this is correct, because the cardinality for set A is equal to 3, and we have 8 subsets. To count the subsets, 2 raised to 3 is equal to 8. Let's have another example. Set C is equal to GLAD. Now, what is the cardinality of set C? You count the number of elements. 1, 2, 3, 4. We have 4. How would we know how many number of subsets we have? 2 raised to 4. That is equal to 2 times 2 times 2 times 2. That is equal to 16. Now let's check in our Pascal triangle. Let's continue. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then 1. 1 plus 4 is 5 plus 6, 11. Plus 4 is 15. Plus 1 is 16. Now we have it. We have one subset containing 0 elements, 4 subsets containing 1 element, 6 subsets containing 2 elements, 4 subsets containing 3 elements, and 1 subset containing 4 elements. 0 elements is always null set. 1 element, we have G, L, A, D. 2 elements, we have 6. We have GL, G, comma L. We have GA, G, comma A. We have GD, G, comma D. We have LA, L, comma A. We have LD, L, comma D. And the last one, we have AD, A, comma D. Now count 1, 2, 3, 4, 5, 6. Therefore, we have 6 subsets containing 2 elements. Let's proceed to 3 elements. My tip for you to easier do this is, since we have 4 elements, 4 subsets, start with G, G, G. You leave the last one blank. You have comma, comma, comma. Then you put L, L, leave the third one blank, and then the letter L for the last one. Comma, A, you leave the second one blank, you proceed with A here, and then another A here. Then we have the D, we leave the first one blank. We have D, D, comma, D. Now you have it. 4 subsets containing 3 elements. For the last one, 1 subset containing 4 elements, obviously that is G, comma L, comma A, comma D. Now let's go back to our cardinality, that is 4, which we have a subset that is 16. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We have it. 16 subsets for a set that contains 4 elements, or the cardinality of the set is 4. Now let's proceed to the next lesson, that is union. intersection and difference. For union, it is a set containing all elements that are in A or in B. So we use OR. And its symbol is U. Remember, U for union. For intersection, it is the set that consists all elements that are both in A and B. So we use AND. The symbol for intersection. For the difference is a set of elements that are in A that are not in B. Example, the difference of A and B. We have elements that are in A that are not in B. And the symbol is the minus sign. Now to apply, we have three sets. Set A is a set of counting numbers from 1 to 10. Set B is a set of counting even numbers from 2 to 10. Set C is a set of counting odd numbers from 1 to 9. Let's have A, C. This is intersection. What is intersection? What is common? What is common between A and C? The number 1. A has 2, C doesn't have 2. Therefore, 2 is not common. We have 3, we have 5, we have 7, we have 9. Therefore, A intersect C is equal to 1, 3, 5, 7, 9. Let's have B intersect C. What is common in set B and set C? As you have observed, there is none. Therefore, it is not set. A intersect B. What is common in set A and set B? Set A has a 1, set B doesn't have. Set A has a 2, set B has a number 2. 4, 6, 8, 10. Next, let's have the union. A union B. Okay, I have mentioned earlier that union is all the elements containing in A or B. Now, first we have 1. Second, we have 2. Remember, we cannot put 2 the same elements in a set. So let's take 2 as 1, 2. Then 3, 4, 5, 6, 7, 8, 9, 10. Next, B union C is equal to B and C. For C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, the same answer. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. For A union C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we have the same answer. Always remember that you cannot write the same element twice. Let's have the difference. The difference of A and C. The question to answer here is, what are the elements that we can find in A that we cannot find in set C? We can find 1 in A, we can find 1 in C. We can find 2 in A, we cannot find 2 in C. Therefore, we start with 2. We have 3, we have 4 here. 6, 8, and 10. But remember that the difference of C and A is different from the difference of A and C. What is in set C that we cannot find in set A? We have 1, 3, 5, 7, 9. Therefore, there is nothing in set C that we cannot find in set A. The answer, null set or empty braces. Another example. Let's have the difference of B and C. What is in set B that we cannot find in set C? There is 2 in set B. There is no 2 in set C. Now we put 2, 4, 6, 8, 10. Another example. The difference of set A and set B. What is in set A that we cannot find in set B? 1. We have 2. We should not list it down. Now 3, 5, 7, and 9. And that's the end of our lesson for today. If you have any questions, just comment it down. And if you want to request other topics, you can also put it in the comment section. Well, next week I am going to discuss Mathematics 7, Quarter 1, Module 2. That will be our topic for next week. And thank you.